Hello and welcome to this lesson on data types and conversion. Today we're going to be addressing the questions, what kinds of data do programs store, and how can I convert one type to another? Our learning objectives are to explain key differences between integers and floating point numbers, to explain key differences between numbers and character strings, to use built-in functions to convert between integers, floating point numbers, and strings. So the first thing to learn is that every value has a type. So every value in any program has a specific type. These can include integers or ints, which are positive or negative whole numbers, like 3 or negative 512. Floating point numbers, or floats, like 3.14159 or negative 2.5. Slight typo there. And then characters, which are single characters, for example, AJ, the number 8, or a parenthesis, where they're enclosed in quotes. It doesn't matter if you use double quotes, like the example here, or single quotes, as long as they match the start and the end around the character. And note that numbers placed inside quotes are treated as characters rather than integers or floats. And then there are character strings. So these are basically sequences of multiple characters inside one set of quotes. Again, single or double quotes as long as they match. And we can use the built-in function type to find the type of a particular value. So here, first of all, I'll just do type and then in parentheses 52. And that, once Python starts up, tells me that this is an int. As well, I can embed that in a print command. So if you highlight a section of text in Jupyter and do Shift 9, so the open parenthesis, it actually encloses that whole thing that you highlighted in parentheses. Handy little tip there. So then I put the print command at the beginning. So I'm embedding the type command inside the print command, and we get essentially the same output, a little messier, but it still tells us it's an int. And remember that having that print command is good practice, good habit to get into, just because if you have multiple outputs within one cell, if you don't use the print command, you're only ever going to see the last output from the code in that cell. Okay, so we can also store values in variables. So we're going to assign to the variable fitness a string called average. And then we're going to print out the type of fitness, which is a variable, so we don't put it in quotes. It's a string. And types control what operations or methods can be performed with a given value. So example here, I'm going to print the result of some math, 5 minus 3. So 5 and 3 are both ints. Run that, we get the 2. So 5 minus 3 is 2. But that mathematical operator, minus, doesn't work with strings. So if I try to print hello, whoops, print hello minus h, and note they're both in quotes, so a string minus a character. Oh, I converted that to a raw cell by accident. That's why it's not running. So convert back to code, run that, get an error, unsupported operand type. So the operand is the symbol, the operator that we use, minus. And, sorry, that's the operator. The operands are the two things we're giving it, hello and h. And those operand types are both string. Python doesn't know how to deal with subtraction when it's given strings. So subtraction doesn't work with strings, but interestingly, addition and also multiplication do work on strings. How do they work? Well, if we do full name as a variable equals, in quotes, Ahmed plus, in quotes, Walsh, so two strings, print full name, run that, we get Ahmed Walsh. No space between, so it just concatenates or sticks those two strings together in the sequence you give them to it, without anything in between. If we wanted a space in Ahmed's name, we'd explicitly add a space. So full underscore name equals Ahmed plus, and then in quotes, a space plus Walsh. And now we print full name again, Ahmed space Walsh. Great. So that's addition. We concatenate the strings that are given in the sequence that they're provided. What does multiplication do? It does repetition. So greeting equals, so our string is going to be hello hyphen times multiplied by 3. Print, so what does greeting become? Becomes hello, hello, hello. So we get 3 copies. So it's basically just taken that whole string and repeated it 3 times, concatenated. Okay, so we can do addition and multiplication with strings and characters, but we can't do subtraction or division, as it turns out. Another property that is characteristic of strings, but not of numbers, so not of ints or floats, is strings have a length. So if I asked for print the length, len, of full name, which is a string that we defined up above, 11. And if you will go up and count Ahmed space Walsh, you'll find it's 11 characters. But the length of an integer or a floating point number is not defined. It has no length. You might think the length of 52 is 52, but it's not. In Python, length refers to things that are represented as sort of a sequence or a number of units that you can sort of divide up and count, whereas 52 is just a number. It's not represented that way. It doesn't have a length. So one of the things about strings and the fact that they have length and the fact that length means that they are actually representing the subparts or the units within the string, the characters, as individual units with positions, is that we can actually use this thing called indexing to pull out specific parts of a string. So here we're going to define atom name equals helium, and then I'm going to print atom underscore name square bracket 0. So square brackets are specifically used for indexing in Python, among other things, but in this case they mean indexing. It won't work if you use round brackets, parentheses there. They have to be square brackets. And 0 is the specific position we want, and that gives us h. So position 0 in the string helium is h. And you can see in this image, E is in position 1, L is in position 2, and so on. And this highlights a really important feature of Python that's important to learn and remember throughout, which is that Python almost always starts counting from 0. There are a few exceptions, but in general you can assume that it starts counting from 0. So the first position in a string isn't 1, it's 0. The second position in a string is 1, and so on. So it's called base 0, counting from 0. Just a handy thing to know and remember. Sometimes a little confusing, but once you get used to it, it becomes pretty natural. So that's indexing to get a specific item within a string. And then we can use slicing as sort of an upgrade of indexing to get multiple values or a substring, a sequence of units from within that string. So now if we define atom name as equal to sodium, and we print atom name and square bracket 0:3, what does this give us? Well, it gives us sod. So if we look at sodium, we're given 0, 1, and 2. We're getting positions 0, 1, and 2. It may be a little surprising that we said 0 to 3, so why didn't we get the thing in position 3, which is the I? The reason is that when you give Python a range of indexes like this, it counts from the first index you give it, so from the 0 up to, but not including, the last value that you give it. So we get 0 and 1 and 2, but we don't get 3. So just like counting from 0, it's one of those things that you just have to sort of learn and remember, and always check your work to make sure you are remembering these things. As before, we can use that built-in print len of a string helium, and the length of helium is 6. 1, 2, 3, 4, 5, 6. And just to highlight, we've been doing this, but just to make it more explicit, what we have here is a nested set of commands. So we have the len command, and we're passing it the value helium, and then the len command is actually embedded inside the parentheses for the print command, and Python evaluates these from the inside out. So in other words, it computes the output of what length helium is, passes that to print, and print prints that result as 6. Okay. So numbers don't have a length, you also can't slice them. So if we say a equals 1, 2, 3, and then print a1, we're going to get an error because an int is not subscriptable. It's just represented as a number. It doesn't represent it as separate sort of 1 and 2 and 3 in different positions that we can sequence through. Now we're going to go into a bit of practice with slicing. So this first example, we're going to say atom name equals carbon as a string, print, and then this is in quotes, so it's going to explicitly print out atom underscore name 1 to 3 is, comma, and then outside of the quotes atom underscore name 1 to 3. So AR. So again, we're counting base 0 counting. So the C is 0, A is 1, R is 2, B is 3, and when we give it a range like that, we go from 1 up to, but not including 3. So we get AR. All right, so now move into some actual neuroscience content. We're going to say cell name is neuron. Okay, it's sort of weak neuroscience content. And then there's a series of questions here. And what I'm going to do is encourage you to pause the video and in your own notebook, work through these examples. First, think about what you think the answer to each of these is going to be, and then actually run it as code and see if you're correct. And some of these you might have to guess because we haven't explicitly taught it. That's okay, and you're going to learn something just from seeing the output. Okay, so pause the video and unpause when you're ready to continue. Okay, so I'm going to make a new cell below, and let's just run each of these to see what happens. Cell name 1:5. Oh, better run cell name first. Euro. So again, we don't start, 1 isn't the first position, it's the second position in neuron. So we get euro, and we go up to, but not including, position 5, which is the N. And make another cell below. Incidentally, if you click a cell, put it in command mode, so it's blue there. If you press the B key, you get a new empty cell below. So what does cell name square bracket 0 to 6 do? Gives us the whole neuron. So 0 is the beginning, 6 is, there's 0, 1, 2, 3, 4, 5. The N is 5. So if we go up to 6, we get up to, but not including 6. There's nothing in 6 anyway, so we get all of neuron. What is cell name? Square bracket 0 colon with no number after the colon. What does that do? Gives us neuron again. So it starts at 0, and if you don't give it a number after the colon, it just goes all the way to the end of the string. What about cell name square bracket colon 5? So we don't give it a number before the colon, just after the colon. Well, as you might guess, that starts at the beginning of the string and goes up to, but not including 5. So you get neuro. Cell name just with a colon, no number before or after, you get the whole string. So the colon is basically the same as not using any indexing. You just get the whole thing. And then finally, cell name square bracket 1 colon -1. What does -1 mean? -1 means 1 back from the end of the string. So the last character in the string is N, so we go 1 prior to that, so we get euro. So again, not starting at 0, starting at 1, going to -1, so we get euro. Okay. Another thing to know is that with these different types, we can't perform certain operations on combinations of numbers and strings. So before you saw that we could multiply a string by an integer, and it would just repeat the string that number of times, but you can't add an integer in a string. So if I ask Python to do that and print 1 as an integer plus string, 2 as a character, we get a type error because that plus doesn't work between an int and a string. So what we can do is print instead 1 plus, and then explicitly run a function called int to convert that 2 in quotes, so 2 is a character, to an integer. Oh, and that should just be 1 plus 2 is 3, okay? So we can use int to explicitly convert that string to an int. And contrary-wise, we can use str for string to convert an integer to a string. Add that to the character 2, and now we're going to get 1, 2, because it's basically concatenating 1 as a character plus 2 as a character. So you get the sequence of them, 1, 2. Now, although there's restrictions on combining strings with integers or with floats, you can freely mix floats and ints in operations because they're both numbers. And basically all that happens is if Python sees you're combining an int with a float, it'll typically upgrade the int to be a float. So in this first case, we're going to say print half is, 1 divided by 2.0. So 1 is an int, 2.0 is a float. It's just going to treat 1 as 1.0, treat it as a float. And the second line here is print 3 squared is, and we're going to give it the float 3.0 star the int 2. Incidentally, the 2 stars together, that operator means to the power of, or in this case, to the power of 2 is squared, right? So half is 0.5, so you can see the result of dividing an integer by a floating point is a floating point, and the result of raising a float to the power of an int is a float as well. So like I say, in general, if you combine ints and floats, your result is going to be a float. Okay, so now we have a series of exercises, and what I encourage you to do is to pause the video again, work through these exercises, and then unpause it, and I'll be working through the answers myself. But it's good for you to practice and think about these things before hearing me talk about them. Okay, so pause the video now and resume when you're ready to go. All right, so hopefully you've worked through these examples. So what type of value is 3.4? Well, we see a decimal point. It's not inside any sort of quotation marks, so it's a float. We can confirm that with the Python command type 3.4. We could embed that inside print if we really wanted to. It's good practice. It's a float. Okay, automatic type conversion. We just talked about this. What type of value is 3.5 plus 4? Well, we see a float, 3.25, and what I said before is that Python upgrades ints to floats. If you combine a float with an int, you will get a float as the output. So we can say print the type of 3.25 plus 4. It's a float. Okay, this one's more of a thought question, and actually the answers are right there. So I will sort of talk about them, but you can also read the answers there. You probably already did. So just asking sort of, okay, what's the best type to use for representing each of these kinds of values? So the first one, number of days since the start of the year. Intuitively, that would be integers, because we tend to think of the number of days as 1 or 2 or 3 or 300 or whatever. On the other hand, we could represent it as a float if we wanted to be more precise and say, right now I'm recording this, it's 2 in the afternoon, so a little more than halfway through the day. So maybe we call this like day, I don't know what day of the year it is, but 250.5, 250.6 if we want that precision. Likewise for number 2, time elapsed from the start of the year until now in days, could be an int, or if you wanted, sort of to be more precise in terms of fraction of a day, you could use a float. Serial number for a piece of lab equipment. Well, sometimes serial numbers are all numbers, so that could be an int. I've never seen a serial number with a decimal point in it, so I wouldn't use a float. But sometimes serial numbers have letters and numbers in them. So in that case, you'd want to represent it as a string, because then you could represent a sequence of numbers and letters in it. A lab specimen's age, well, you could represent this as an int if it just mattered like how many days old it was. You can measure it as a float if you want it to be more precise in terms of number of days or sort of hours or something else as well. Not covered in this lesson, but Python actually has other types besides floats and ints that specifically are used to represent time. So Python has time-related types. So you could actually represent the age in terms of literally minutes or hours or seconds or a combination thereof. It's a bit advanced. We're not going to cover it in these lessons. Current population of a city. Well, we tend to count people in terms of units of human and not subhumans, so it doesn't make sense to talk about 0.5 or 0.6 of a human. So population, we would use integer. But if we want average population, when you compute averages, you almost invariably get a floating point number. And so you'd need to represent it as a float, unless you wanted to round up to an integer. Both are actually valid. Okay, and this brings us to the fact that in Python there's actually 3 different types of division. Simple division is a slash, so I'm actually going to run this one first, even though it's not first in the notebook here. So if we do 5 divided by 3 equals, comma, so that part in quotes is my string, so Python will print that out literally, and then it'll compute and print out the actual result of dividing 5 by 3. So our answer is 1.6666666666667. So it's 1.6 repeating. At some point, Python truncates that and rounds it up. So you get the 7 at the end. So that's a float, right? Decimal point in it. Now let's go up here and see what happens when we do 2 slashes, which represents what's called floor division, or whole number division. So 5//3 equals, and then actually write that out as an equation. So 5 divided by 3 equals 1. So basically it computes the result and then rounds it down. Even if it's, so 1.6 greater than 1.5, so it's not typical rounding that would round that up to 2, it rounds it down. That's why it's called floor division. So this can be handy if your output needs to be an int rather than a floating point number, because floor division will always give you a rounded integer. The other type of division in Python is modulo division, using the % sign. So print 5 modulo 3 equals, and that as the equation. So what you see here is that gives you the remainder from integer division. So in other words, we do integer or floor division. 5 divided by 3 is equal to 1, so the remainder is 2. So 2, like 1.6667 is basically 1 2/3, right? So 5 divided by 3 goes into 5 once with a remainder of 2, so the modulo is giving you the remainder as a whole number. These can be handy in various situations that we will likely encounter in this course. One example using floor division specifically is this division challenge. So imagine we're catering an event for 100 guests, and for dessert we want each person to have 1 slice of pie. Each pie yields 8 pieces. So how do we calculate the number of pies we need? So we can start by simply dividing the number of guests by the number of slices per pie. So you can see here we define pie eaters as a variable equal to 100, slice per pie as equal to 8, and then we compute the division. So numpies equals pie eaters underscore slice per pie. Then we print out the results. So I'm going to type that out, and as I do, I'm going to sort of comment as well. So pie eaters equals 100. So the reason that I really shouldn't try and type and talk at the same time when I'm not talking about what I'm typing. Slice per pie equals 8. So why do we define these 2 variables? Because we could also just say numpies equals 100 divided by 8, and that would be less lines of code. Sort of makes sense. It's a little more efficient. The reason that we define these variables, this is good coding practice, because later if you come back to your same code, or if somebody else is looking at your code, if they just see 100 divided by 8, they may not know what those numbers represent or how you got there or why you did the math the way you did. So by giving those values explicit variable names, you're making your code more readable and interpretable by explicitly saying what those values are. The other reason is that in this example we have one equation, numpies equals pie eaters divided by slice per pie, right? So one equation. So it's not that much to change. But if we actually ended up, later we're going to change the number of pie eaters. If we had a larger program that was using those variables, pie eaters and slice per pie, a few times in different equations throughout the code, it would be really difficult to change any value. So if we didn't define a variable as pi-eters once as equal to 100 and then just use pi-eters later, and we sort of used 100 explicitly throughout our code, when we wanted to change the number of pi-eters, we'd need to do a search and replace, go through all of our code and change every value of 100 to whatever our new value was. And it could actually get complicated because maybe you used 100 for pi-eters, but maybe 100 was also used in your code in other places. So you wouldn't just blindly search and replace every instance of 100. You'd need to manually go through the code, find all those instances, decide if that 100 in that use case actually represented pi-eters, change it there. So it's grossly inefficient. So it's much more readable and ultimately more efficient if you define these things as variables. Okay, so let's print the result. Print pi, oops, sorry, not as a string. Print the variable pi-eters, and then guests, and then requires num pies variable, and then the string pies. String pies. Okay, so 100 guests requires 12.5 pies. Now, the problem with that is you can't bake half a pie. You can only bake whole pies. So we need to round up. So we need to know that ultimately what we want it to tell us is we need 13 pies to ensure we have enough for everybody. Even if we have a bit of leftover, that's better than some people not getting pie. So we can use instead floor division to get a whole number. So num pies equals pi-eters slash slice per pie. And right here you see the beauty of having defined pi-eters and slice per pie as variables. We don't need to type in those numbers again, we just use those variables. Print pi-eters as a variable, guests, and another thing, we don't have to say guests as one string comma requires, we could just say guest space requires. The comma tells Python to add a space between those two things, but we can also do it this way. Num pies, comma, and then pies. Okay, so 100 guests requires 12 pies. So good in the sense that it's now giving us a whole number result. Can't bake half a pie, but bad in the sense that we're shorting 4 people their slices of pie, because we actually need 12 and a half at least. We want to go up to 13, not down to 12. Problem is that Python doesn't provide an operator for rounding up, or what you might call ceiling division. So the solution is to add 1 to our answer. Okay, and so you can see here numpies equals pi-eters slash slice per pie plus 1. Also note that Python uses the standard order of operations that is followed in mathematics. You probably learned in grade school somewhere along the way. So if we say pi-eters slash slice per pie plus 1, division has precedence over addition. So it's equivalent to this format, this format where you put the division in parentheses, which explicitly says do this first plus 1, and it's not that we're adding 1 to slice per pie and then doing the division. But sometimes you might want to use those parentheses to sort of enforce an order of operations that isn't the default, or just to reinforce and make your code a little more readable. But you don't have to. So here num pies equals pi-eters slash slice per pie plus 1. And I'm just going to cheat and copy and paste my print command from the previous cell because it's the same. So 100 guests requires 13 pies. Great, we're definitely going to have enough pies now. No problem, seems to work. However, in coding, it's always good to think about different scenarios and test your code and think, are there situations where it's going to break? In this case, where our code is going to break or give an incorrect answer is if the number of pi-eters is exactly divisible by the number of slices per pie. So here in this example, we have pi-eters equals 64. Of course, 64 divided by 8 is 8, so that's a whole number. So what happens when we compute numpies to to be equal to pi eaters / slice per pi plus 1. Paste our print command. Well, first of all, we have to type things correctly. Okay, 64 guests requires 9 pies. So the problem is it did 64 divided by 8 is 8 plus 1. So even though we actually only need 8 pies plus 1, it gives us 9 pies. So when the number of pie eaters is precisely divisible by the number of slices per pie, when we add 1, we actually end up with extra pie. It's probably better than having too little pie, but if you're running a business and every pie costs you money, then you've got wasted food, right? So here's the solution, and if you were working through this on your own, you may or may not have got there on your own. It's a bit of a tricky solution, but numpies is equal to, and then in parentheses, pi eaters minus 1. So we'll subtract 1 from the number of pie eaters first, then divide that by slice per pi, and then add 1 to the result. So in this case, pi eaters starts out as 64, minus 1 is 63. Divide 63 by 8, then add 1. Add a space there. And let's paste our print command again. So now 64 guests requires 8 pies, so it works. So just a little trick that gets us to the right answer. Okay, going back to types and conversion, where reasonable, float is an explicit Python command or function that'll convert a string to a floating point number. And corresponding, there's an int command that'll convert a floating point number to an integer. It'll also convert a string to an integer, as it turns out. So, for example, if we print string to float, and then give it as our input a string of 3.4, and then also print float to int 3.4, run those. So string to float is 3.4, float to int is 3. So the first one, sort of confusing, but it doesn't really show us here if the result is a floating point or a string. But if we say string to float, if we embedded that in the type command, string to float, the result is a float. Float to int, that's the one where we can see something happen because the input was a float 3.4. When we run the int command on that, it actually truncates the decimal point. It doesn't round, it just chops off anything after the decimal point and gives you the whole number part of that number. So just 3. Okay, and you can prove it doesn't round by saying 3.9, because if it rounded, 3.9 would go to 4, but it's still, the result is 3. Okay, however, sometimes the conversion doesn't make sense. So what if we try to print out the result of string to float, and then give it hello world. So hello world is a string, but how do you convert that to numbers? Those aren't numbers, those are letters. So it has no way of dealing with that or figuring out what you want to do. It gives you an error. Another thing you can do is, well, first let's think about this. What happens if we convert a fractional string to an int? So 3.4 is a string passed to int. So up above int of 3.9 or 3.4 would give us just the truncated, the 3, right? But now there's sort of 2 steps, because it would have to go from 3.4 as a string to 3.4 as a float to 3 as an int. And Python won't do those kind of 2-step conversions. So print fractional string to int 3.4 gives us an error. Sort of a confusing error if you don't really know what's going on, but basically, as I say, it won't do 2 steps of confusion because it doesn't really know what to do. Okay, but you can, you can make that work by a 2-step conversion. So if we say int and then explicitly run float on the string 3.4. Again, Python works from the inside out, so it's going to run float 3.4 first, generates a floating point number of 3.4, converts that to an int, and you get a 3. All right, and finally we have a little exercise, and I'm not actually going to work through that because it's pretty easy for you to do. But the good thing to do would be to pause, look at these different scenarios, and think about which one of the following will return the floating point number 2.0 before you actually run the code. Just test yourself on your understanding by thinking through what's each of these going to generate, and then run it in the cell below and see if you were right or not. And there may be more than one right answer, so maybe more than one of them actually return the floating point number 2.0. All right, so that brings us to the end of the lesson. So just to summarize, every type in Python, every value has a type, be that a float or an int or whatever. You can use the built-in function type to find the type of a value. What type of value is controls what operations can be done. So for example, strings can be added and multiplied, but they can't be subtracted or divided. Strings have a length, but numbers don't have a length. With strings, we can use an index to get a single character from a string. So remember, the indexing starts at 0 and goes up. So if we use square brackets, variable name and then square brackets with a single number, that'll give us the value at that string, the character at that string corresponding to that position. We can also use slicing with a colon to get a substring. We can use the built-in length function, len, to find the length of a string. But of course, numbers don't have length. And if we want to do operations with numbers that are represented as strings, we have to convert them to numbers using either the int or the float commands, or both. Or vice versa, if we want to treat numbers as strings, we need to explicitly convert them to strings and then run the operation. But we can mix integers and floats freely in operations. And generally, as we've seen, what happens is you upgrade the int automatically to a float, and your result is a float. All right, so thanks for watching. That's the end of the lesson, and we'll see you next time.